Hi, I'm 𝐚𝐭𝐜, the container guy. Today, we're going to be modifying this 53-foot X Reefer shipping container. In this can, we're going to be installing 2 overhead doors, 2 man doors, and a bunch of custom framed cutouts for customer supplied intake and exhaust louvers. The customer was able to use our online 2D modification planner tool at planmycan.com to place the overhead doors and the man doors exactly where they wanted them. You'll see here we've marked out all the doors and everything already, and we've got the container up on our modification beams just off the ground. We've supported the underside of this container in a couple places just so that as we're cutting the openings out prior to installing the frames, we make sure that we support that floor and don't get too much sag. Another thing to note is when we do cut these out, which we'll be doing right away here, is we use a metal cutting skill saw. So this saw right here, it's got the carbide tooth blade on there. It works really well and goes through the aluminum very easily. The wall cavity here is just a lighter gauge exterior aluminum. There will be studs every 2 feet or so. And then on the inside, it's that white fiberglass FRP panel. So we will let the boys get at it and check in on them after they've cut out all the rough openings. So we're back here to check in on the boys. It looks like they've already installed the man doors. I'll just go over them a little bit. So these doors here, they're getting installed on this aluminum insulated container. Difference with the install is that up at the header, we don't use the rain drip because we want to leave the container as insulated as possible. Once I jump inside, I'll show you what that means, but you can use the rain drip. It's optional if you want to use one. You want to use the end wall version, not the sidewall version, which has the angled profile. To give you an idea how this door works here. So it's got the automotive grade door seal that closes and seals very nicely and allows for flexibility and movement. And here is the inside of the door. You can see we've cut the hole as tight as we could so that we'll be able to actually just either silicone that or up at the top. You can stick a straw of spray foam and then silicone. So if we were to use the drip edge, we would have had to cut this opening 2 inches higher, and then we would have had this hollow void here with no insulation. So we chose not to. Up at the top on the outside, we'll just silicone the top edge. If someone's concerned about water intruding in, you can use that rain drip, but then you either have to fill it with foam or you can cut a sliver of this insulation and the FRP panel and slide it back into that header as well. It's another way of insulating it. So yeah, this can's insulated and so are the doors. They're rock wool insulation built to a 60-minute fire rating spec. All of the openings are cut out now. Here, this is a intake louver for the large exhaust fan that's going in here. This container is going to be used for a very large air compressor and an air dryer. That's what will be going inside of these large insulated overhead doors. So they've got the 2 overhead doors cut out. We're just waiting on the special frames that we had to do up for this type of container. This is the exhaust vent. We'll just finish trimming this up. The customer is going to be installing everything themselves, so we're just cutting out the openings and then providing them a galvanized flashing, something more structural that they'll be able to screw into. So here they're going to have a heat and AC unit just to help temperature control this thing. It's going to get super hot in the summertime. They'll probably just continually run that fan to be exhausting all the hot air out, but in the winter they'll probably not run that. And the air compressor probably generates enough heat to heat this building, but if not, there is some auxiliary heat here. So yeah, second overhead door, another man door for access because you won't be able to get around the generator that's in here, and then the other louvers. So they'll be pulling air from kind of the bottom on both sides and then across the can out the exhaust vent. And so here on the end wall, one of the cutouts from the overhead doors, we've reused the cutout. So we have a similar interior finish on the inside of the can. We like doing it this way. So Here we got the fiberglass FRP panels, the same 2 inches of foam, and then on the outside we've left a flange all the way around that allows us to self-tapping screw back into the frame here, and then if there's any little gap there, we'll fill that up with foam and silicone. One thing I'd like to point out is when you're marking out your openings for cutting into the structure of these containers, they have vertical studs running every 2 feet or so. So rather than install this opening right here and get rid of 2 of the structural J channels, we can just center it in between and only get rid of 1. So if you do proper planning when you're modifying these X reefers, same goes here, then you're gonna make sure that, yeah, you retain as much structure as you can and reduce the, you know, opportunity for sag. So we've centered the man door between 2 posts. We've only cut through 1. I think the customer wanted it, you can see right here, they wanted it this far over. We've just gave them a call and said, hey, if we move it over this far, does it matter? Because it's gonna make your can a lot stronger. This container had a few cuts and bruises on the outside, so another thing to show you is we had to do a few patches. So from the other cutouts, we've taken the same aluminum sheeting that's on the exterior of the container, cut out a patch larger than the hole, drilled multiple holes in it, riveted it all the way around, and then a very good silicone job to make sure that no water protrudes through the opening. So I'm just getting back to the yard. I was at the steel processors. We picked up the overhead door frames. We had to develop a special overhead door frame for this customer because the height requirements of the compressors that are going in this container. So a lot of times we have to go back to our 3D modeling software and tweak our model just to meet our customers' demands. And so yeah, definitely this time there's some custom framing required. And so here is our overhead door frames. These are slightly different than our roll-up door frames. It's more of a J-channel style that surrounds the foam wall structure that it's encompassing. So the header here, this is on the outside, this is on the inside. For the overhead door, we do a nice big tall header that helps, you know, span that distance, but also in the middle gives the overhead door installers a place to mount their spring hardware. The threshold plate, we return fold it downwards. That allows us to bolt into the bottom channel or footer of the container just to help with the rigidity of the 7-foot span here. And then finally, these side pieces are very similar to our roll-up door sides, just slight tweaks for the way that the header connects to them. And then still on the inside of the can, we allow it to come further up, and that's where the overhead door installers will install their tracks. So we got the left, right, and lastly the header. So these are all purpose-built for this exact modification, this exact customer's demands. Ever any other customer looking for something completely custom, we can always play around with our spans. We don't like to go much more than, you know, typically 8 feet on this style of container, and you know, you can span up to 10 on the steel corrugated containers, but beyond that, then you get into needing some, you know, engineer stamped structural kits. Now today, new day, we're just gonna get this these 2 frames installed and ready for the overhead doors that are coming tomorrow. So one thing I'd like to note about these door frames is that the order is slightly different than the roll-up doors. So we actually start with the footer on these ones so that we know our framed opening width. And the reason for that is because up at the top on the headers, the side frames don't connect to the header, which they did on the roll-up door frames. So order of this is the footer, the 2 side frames, and then we slide the header up, make sure everything's all squared up. We use a 5/16 self-threading bolt into this thick aluminum frame down at the bottom, and then just rivets all the way around for the rest of it. So we'll get started. So Riley just pre-drilled the first 2 holes. We are going to just throw in the first couple self-threading bolts. Just that'll hold the footer in place, and then when we continue to drill, the footer's not moving around and our holes are actually in the right spot. So these are an awesome case hardened screw. They're super high shear strength on them. So yeah, we use those screws often when we need something bigger than the 1/4 inch self tappers. We'll let Riley finish up here. and then get on to the side frame installation. Another thing to note is we were using a 9/32 drill bit. That size can potentially change. So I think this beam here is like 3 millimeters thick. So depending on the material thickness that you're going into, you might need to upsize or downsize that drill bit. With this footer here, now that it's all screwed in, it's solid. So normally we actually laser cut holes to be able to screw them into the wood floor containers, but this one isn't wood. But the threshold plates are not typically return folded downwards. So with this, it's actually a lot more of a solid connection even without any screws here than what a normal threshold plate would be in the wood floor. So we're happy with it. So make sure everything's all flushed up nicely here. Riley's pushing on it and held it in place there for me. So we just want to tack the bottom corners of the side frame. Now that's held in place, we'll do the same thing on the other side, and then we'll jump up to the top and make sure that the framed opening's nice and square, and then get the header tacked up and finish up the sides. So we've got the header held up here. We can kind of square it off, make sure that the opening's square. Then we'll jump inside and we'll just tack it in place with a few rivets up at the top there, and then we'll jump back out here. We have to pre-drill the hole, so we want to hit these aluminum studs in these aluminum containers. So we're going to pre-drill where the studs are, and so it's a good idea just to measure corner to corner and make sure that you're square. Bang on. So if you've ever installed an overhead door, you know that your tracks actually come up higher than the door opening itself, and that's why we continue these side frames further up, as pretty much as high as we can go to the roof. And then we've also laser cut holes up at the top here to make sure that we're hitting this aluminum flashing. So here at the header, we just have to push up to make sure that it's nice and level across at the bottom of the header. So now we got that tacked in. We'll just quickly rivet the side frame and continue on all the way along. So we got the header up in place here. We're gonna tack the two front corners of the header just to make sure that the opening's nice and square. And then once we have those tacked, we're going to drill through the aluminum studs that are in this container, and then use our 5/16 self-threading bolts in there because they're much stronger than a 1/4 inch rivet or self-tapping screw. So we have this container all ready. The frames are in and prepped for the overhead door installation. The contractor is coming tomorrow to install the doors, and hopefully they'll allow us to follow along as they get those installed and show you guys how that's done. Hey, so we're back here. The installers, we got a few clips of them yesterday putting this door in, but they finished up last night while we were gone. So I'll just go through the pros and cons of these doors, and then we'll take a look at how it was installed. So first, these overhead doors, they're available in insulated and non-insulated options. So when we're using a 53-foot Reefer container, we're able to select an insulated door, and that's the big key here. Is this customer is going to be heating this can, and they need that insulated door. Reason why we don't go with the tin roll-up doors that are just a sheet of steel that condensate and sweat throughout the winter. So great that these door slabs are insulated. The con to these is that they go up and inside the can and remove headroom in the container. So there's a max height of shelving or components that they can put inside this can, because it does take away from their interior headroom. Our framing kit allowed them a very nice finish here to install their weather seal. A few things to note about these doors: it's a commercial slab, and then they use a 2-inch residential track. That track allows the 12-inch radius and gives us the maximum height on the interior, where commercial tracks often are 15-inch radius. So yeah, we get that max rough opening height with this combo. Make sure that your containers level when they show up. So if your container, we've had this happen before, is sitting on an angle, they'll bring their level here, they'll install the door perfectly plumb, and then once you level your can, your whole door will be a parallelogram one way or the other and not operate properly, because it needs to be level side to side to run down the tracks properly. Another thing about these doors is that common stocked panels are 21-inch or 24-inch heights. So if you can size your door openings that match those, then the installers don't have to trim these panels down and cap them. So to save money, if you can size your door openings to be multiples of 21 or 24-inch door slabs. Now we'll jump inside and take a look at the mechanics of this door and show you how well this thing seals up. Another thing here is this is a manually operated door, so it's just lift. It's spring tension that allows it to raise and stay up high. These do come with electric operators. They have two different types. There's either the one that just runs along the center like every garage door, or there's actually a side operator system. So on the side walls of containers, we actually like to go with that side operator. But when we put these overhead doors in the end wall of cans, there's no room on the side to mount that, and then we're stuck with that centralized electric operator. So here's the inside of the door. They come with an interior locking mechanism. We got the rope here just to help you grab the door and pull it downwards once it's open. These doors here use a 2-inch, it's a residential style track. That track allows us to have the 12-inch radius, and then it allows us to spec our door openings as high as we possibly can. One thing I learned from the installer there yesterday is that actually, you know, they can kind of even get away with like a 10-inch header height and squeeze these doors in. They prefer 11 or so, but I always thought that was 12 inches was the dead minimum. So interesting to know, if we ever need to squeeze for a customer, we can. But yeah, if you see up here, I talked about earlier about the side frames that the installer needs to be able to secure their track to that. There always needs to be something dead center of the door where they can mount that middle plate. One thing to caution is always talk to your overhead door installer or the contractor that arrives to do it, and make sure that you explain to them where they can and cannot mount their tracks. So we've had, if they just show up and get things done, we come inside a can and they've got screw holes all the way through the roof of a brand new container, and it's horrible. So yeah, I always have a plan for them where they can secure their tracks. They're gonna need to secure them on the opposite end of the can. So this being an insulated container, it's 2-inch thick wall system, 3.5 in the ceiling. They were able to use tech screws and secure their perforated angle iron up the roof there. And it's a nice durable connection that will support the weight of the door when it's fully open. So that pretty much wraps up our scope of this project. The customer still has a bunch more work to do in this container once we deliver it to their site. I'll just crack open the doors and give you guys a final tour of how everything landed. One thing to note about these Reefer doors is that they've got like 4 door seals on them. So if you try to open just one door at a time, they seem to jam. So a trick here is when you're opening the doors, you just get the first one popped, and you gotta go and open the second door, and then they open nice and easily. And so here we can just jump inside and give a look at the final modifications that we performed on this container. And so here is the first man door. It's right close to the container doors. We have our frames all installed. That's where their intake damper is going to be, which pulls the air in for their exhaust fan. Their first overhead door, so here will be either their compressor or their air dryer, not sure. 2 openings here, so that is their exhaust fan, and then we got our heat pump and AC unit. The final overhead door here with the man door, that just provides them additional access into this end of the container. It's probably going to be pretty tight walking around this. And then the final intake damper. These aren't fully finished up, but once their unit mounts inside here, that's going to seal everything up. They'll be able to silicone around all of our flashing kits that we provided them, and this thing should be pretty tidy. So that concludes this compressor shack modification inside this 53-foot Reefer container. If you enjoyed this video, please smash that like button. If you found it informative or you have any additional questions, please feel free to leave a comment below. As always, please subscribe to our channel and ring that bell for notifications. Hope you learned something.